What's going on, everybody? Got another video here for you, another business calculus. I'm just about finished wrapping this series up. Got a few more videos to do. All right, so let's look at this one. We got antidifferentiation, the indefinite integral. All right, so in the class, if you're taking business calculus, so far you've learned how to find derivatives. Now we're going to do antiderivatives, or integrals. So antidifferentiation, a function capital F of x is said to be an antiderivative of little f of x if capital F prime of x is equal to little f of x. So in other words, this function here, capital F, is an antiderivative if you can take the derivative of it and get little f. And that's for every x in the domain of little f of x. The process of finding antiderivatives is called antidifferentiation or indefinite integration. All right, so let's look at some examples. We've got several examples where we're going to do antiderivatives, and then we've got several word problems that we have to find antiderivatives. So there's going to be a bunch of examples. All right, so it says verify that 1/3. So we'll just call, we'll call this, well, let me change the color. So we'll call that big F, this right here, is 1/3 x cubed plus 5x plus 2. And this is a 3 here. And verify that it's an antiderivative. So if we take the derivative of this, f prime of x, so remember, 3 comes down, 3 times 1/3 is 1, subtract 1 from the exponent, so that's x squared, plus, and then the derivative of 5x is just 5, and you can see we get little f of x. So this right here is an antiderivative because we were able to take the derivative and end up with this little f here. All right. All right, so let's look at this. Fundamental property of antiderivatives. If big F is an antiderivative of the continuous function little f, then any other antiderivative of little f has the form capital G equals little f plus c for some constant c. I'm going to talk about this plus c in a minute. All right, so here's an integral. This right here is our integral symbol. The function here, that's your integrand. This is the variable of integration. That's what you're integrating with respect to. And then c is your constant of integration, and this is an indefinite integral. All right, so whenever we integrate, and we're fixing to have some rules here that tell us how to integrate functions. But whenever you integrate, you have this plus c, plus a constant. Now, c is some number. Well, what number is it? Well, I don't know. Okay? We don't know what number it is. But you'll see when we get into some other problems, word problems and stuff, that we will be given some extra information so that we'll be able to find c. And so antiderivatives, if you find the antiderivative of a function, there are many, 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 many antiderivatives to that function. So, I mean, if you look at this, so you agree this is an antiderivative to this function. So if you look at x squared plus 5, this is the antiderivative to it. But look at this. Isn't 1/3 x cubed plus 5x minus 3? This is also an antiderivative to little f, because if you take the derivative of this, you end up with little f. So see, c, I mean, we can just sit there and just keep changing the constant forever, and we'll get an infinite number of functions that if you take the derivative of it, you're going to get little f. So this has an infinite number of antiderivatives. Now, we're going to work some problems later on, like I said, where we will be able to figure out what C is. Okay? But just remember, whenever you're integrating an indefinite integral, you have to add that plus C. And make sure you don't forget it. Okay, I've had students taking tests and they got all the integrals, that they integrated everything right, and they left off the plus C on every problem, and that's -1 every time you do it. Okay, so don't forget it. All right, so now we got rules for integrating common functions. So if we have the integral of k, so k you can see is a constant, it's just some number. So if we integrate some number with respect to x, then it's just that number times x plus c. Here's the power rule. This right here is probably one of the most common ones that you're going to use. So if we integrate x raised to a power, well, what do? Well, you add 1 to the exponent and then multiply by the reciprocal of your new exponent, and then plus c. And this is for when n is not equal to -1. And then we have logarithmic rule. So if you integrate 1 over x dx, that's the natural log of the absolute value of x plus c. And of course, x cannot be 0 because you can't take the log of 0. And also, if you remember, you cannot take the log of a negative number, and that's why we put the absolute values. So don't forget to put your absolute value there so we can make sure that x is positive. And then we have exponential rule, e raised to the kx. K is a constant and it's not equal to 0. Then the integral of that is 1 over the constant times e to the kx. So it's just the answer is just whatever you're integrating. See, it's the same thing, but then it's times 1 over whatever that constant k is. All right, so let's look at some examples. Well, let's see. It's not wanting to move up. There we go. All right. So here we go. All right, so let's integrate this. Well, what does this equal? This is what? That's just 3x plus c, right? Based on this, 3 is a constant. 3 times x plus c. All right, so what about this one? Well, this is equal to x to the 18th. We add 1 and then times the reciprocal of the new exponent plus c. And there's your answer. Now, let's look at this one. That's 1 over the square root of x. We don't have anything that really tells us about that, right? You look at that 1 over square root of x and you might think, well, is it this one? Well, no, it's not this one because this is 1 over x, not 1 over the square root of x. So one of the things that you may have to do, and this is very common when you're doing integrals, is rewriting the problem so it looks like one of your formulas you have. Okay, very common. There's actually whole sections on methods just to rewrite the problem. Okay, so it can take you longer to rewrite the problem to make it look like a formula than it does to just integrate the thing, to actually do the rule for your integral. So what do we know? Well, the power rule. We know how to integrate x raised to a power. We know how to do that. So what if I rewrite this thing as the integral of 1 over x to the 1/2, right? Square root of x, that's the same thing as x to the 1/2. And then we can write that as the integral of x to the -1/2 dx, right? Because all I know how to integrate is x raised to a power, right? And so now here I'm going to get x raised to the, and what do? We add 1. -1/2 plus 1 is 1/2. multiply by the reciprocal of your new exponent. So the reciprocal of 1/2 is 2 plus c. And then you can write 2 square root of x plus c. And there's your answer. And then what about this one? Well, this one's just what? E to the negative 3x. And then it's times what? Times the reciprocal of that constant. So negative 1/3 plus c. And notice how I did not forget to put plus c in any of my answers. Make sure you do not forget to put plus c. All right. Now let's look at this. We've got algebraic rules for indefinite integrals. So we got a constant multiple rule. So this is saying k times f of x dx is k times the integral f of x dx. So all this one's doing is saying if you have a constant, you can pull it outside the integral. You can't pull a variable out. Like if you're integrating with respect to x, you can't pull an x out, but you can pull out a constant. And then this sum and difference rule, that just means if you have several terms added or subtracted together, you can just integrate each one of them individually. Okay, so let's look at some more examples. So let's look at this one. So we've got several terms. We're just going to integrate each one of them individually. So this is going to be 2x to the 6th, right? Add 1 times the reciprocal of your new exponent. Plus 8 times x to the 4th. Add 1, right? Add 1 to the 3. And then times the reciprocal of your new exponent. Minus, and then that's 3x cubed, add 1 to the 2, and then times, I keep doing that, times the reciprocal of your new exponent, plus, and then the integral of a constant is just 5 times x, and then that's plus c. And so this is 1/3 x to the 6th plus 2x to the 4th minus x cubed plus 5x plus c. And you know, if you want to, and see how I wrote the 1/6 out there, if you want to just say, okay, times the reciprocal of 6, 1/6 times 2 is 1/3, you can do that part in your head. You don't have to write all this out. You can just go straight to 1/3, go straight to 2. You know, if you want to do that, that's fine. All right, so let's look at this one. So this one's kind of interesting here. We don't have any kind of rule that shows us how to do some kind of fraction like this. Really, when you think about it, all we know how to do is x raised to a power. And then, of course, we know 1 over x, and we know e raised to a constant times x. We know that. But let's look at this. Let's see if we can get this in a form that we need so we can integrate it. So if I rewrite this, I can write this as x cubed over x plus 2x over x minus 7 over x dx. I can split the fraction up, right? And so this would give me x squared plus 2 minus 7 over x dx. Okay. All right, so I know how to integrate this. I know how to integrate this, and actually we do know how to integrate this, but this might look kind of funny to you because we got 7 over x, and notice in our formula up here we don't have 7 over x or a number over x. We have 1 over x for logarithm. Whoop. Here we are. So I'm going to do this extra step here. This is not a step that you have to do. I'm just going to do it because maybe it might help you see it better. So this is x squared plus 2 minus, now this 7 over x, wouldn't that be the same thing as 7 times 1 over x dx? I could write that like that, and now we can see the 1 over x. And so this is just going to be x cubed times the reciprocal of your new exponent, which is 1/3, plus 2x minus 7, and then the integral of 1 over x is natural log absolute value of x plus c. And notice once again, I did not forget my plus c. We cannot forget the plus c because we get points taken off for that. All right, what about this one? Okay, so this one's fine. Well, this one's fine right here. We know how to do that. And we did integrate a square root earlier, right? What did we do? We just rewrote it. That's 3e to the negative 5t plus plus t to the 1/2 dt. And so this is going to be 3e to the negative 5t times the reciprocal of the constant in front of t, and then plus t to the add 1, so that's 3/2. 1/2 plus 1 is 3/2 times the reciprocal of your new exponent plus c. So that's going to be negative 3/5 e to the negative 5t plus 2/3 t to the 3/2 plus c. And there's your answer right there. All right. Okay, so now let's look at this. All right, so now the rest of the problems are word problems, okay? But we're going to have to integrate in order to solve them. All right, it says, find the function f of x whose tangent has slope f of x equals 3x squared plus 1 for each value of x whose graph passes through the point 2, 6. All right, so think about what they just gave us. They gave us the slope. Okay. And I actually copied the problem down wrong. I should not have put the f of x. It's just who has slope 3x squared plus 1. Okay. All right. So we want to find the function. So they gave us the slope. This right here is the slope. Do you remember how we found the slope of the tangent line to a curve? How did we do that? We took the derivative of the function, didn't we? So would you agree that f prime of x is equal to 3x squared plus 1, right? Because that it tells us this is the slope, so this would be f prime of x. Okay. Well, now how can we get f of x? Well, we can integrate this. So we get f of x is equal to the integral 3x squared plus 1 dx, which is equal to 3x cubed times the reciprocal of your exponent plus 1 times x plus c. And so I get f of x is equal to x cubed plus x plus c. All right. So here we go. All right. So we found the antiderivative, and like I said, don't forget that plus c. But look, in this problem, we can figure out what c is, can't we? Because, and why is that? Because it's telling me it passes through the point 2, 6. So if I plug this in for x, then I should get this answer, right? So if I take the 2, plug it into my function, that should equal 6, right? And so this tells me this is 8 plus 2 is 10, right? Plus c equals 6, so c equals negative 4. So see, I was able to find, I'm sitting there hitting buttons. So I was able to find c. Well, it doesn't look like a c, but it is. So c is negative 4. So I can replace this c with negative 4. So that gives me f of x equals x cubed Let me write the 3 better. X cubed plus x minus 4. And so that's your function right there. All right. All right, so now let's look at some other problems. All right, so some of these problems, they're going back to what we learned earlier, marginal cost. See this example? So it says a manufacturer has found that the marginal cost is this dollars per unit when Q units have been produced. The total cost of producing the first 2 units is $900. What is the total cost of producing the first 5 units? All right, so think about what they gave us here. They gave us the marginal cost, right? So that would mean DC dQ, right? Isn't that what the marginal cost is? The derivative of the cost function, right? I know we could write this C prime of Q. We could write that. But doesn't C prime of Q, that means the same thing as derivative of C with respect to Q. Okay, it doesn't matter how you write it. That is equal to 3Q squared minus 60Q plus 400. And so now let's integrate it, because what are they wanting us to know? What do they want to know? It says, what is the total cost of producing the first 5 units? So if they want to know the total cost, then that means we have to find the cost function. So if the marginal cost, if this is your marginal cost, this is the derivative of your cost function. So to get to your cost function, you have to integrate this. And so I've got C of Q is equal to the integral 3Q squared minus 60Q plus 400, and we're integrating with respect to Q. All right, so let's see what we get here. So we're going to get C of Q is equal to, all right, now let's do something different on this one. So what do? I add 1 to the exponent, right? 2 plus 1 is 3. Multiply by the reciprocal of your new exponent. What's the reciprocal of 3? 1/3. 1/3 times this 3 is 1. So this is Q to the 3rd. Minus, and then here, that's Q to the 1st. So I add 1, that's 2. So that's Q squared. What's the reciprocal of 2, my new exponent? 1/2. What's 1/2 times 60? That's 30 Q squared plus 400 Q plus what? Plus our constant C. Okay, so I used a K. Typically, you use C. But I'm using a C right here to represent my cost function. So I don't want to use a C over here because I don't want to get this C confused with this C. Okay? All right. Now, we've got to find the total cost of producing the first 5 units. Well, what does it tell us? It says the total cost of producing the first 2 units is $900. So that tells me if I take the 2 and plug it in for Q, right? So if I do C of 2, okay, we're plugging 2 in for Q, what should I get as an answer? I should get 900 as an answer, right? So if I do C of 2 is equal to 2 cubed minus 30 times 2 squared plus 400 plus K, that should equal 900. Okay? And then when you take this equation right here and you solve it for K, you're going to get, and you can plug all that in your calculator, add all that up, and then subtract it to the other side. You're going to get K is equal to 212. So I get C of Q is Q to the 3rd minus 30q squared plus 400q plus 212. There's my cost function. And what do they want to know? What is the total cost of producing the first 5 units? So all I have to do is take my cost function and plug 5 in. That's 5 cubed minus 30 times 5 squared plus 400 times 5 plus 212. And when you punch all that in, you're going to get $1,587. And there's your total. There's your total cost for 5 of them. All right, let's look at this problem. This looks complicated already, doesn't it? Look at that. Look at this function here. All right. All right, so it says the population P of T of a bacterial colony T hours after observation begins is found to be changing at this rate here. dP dt is 200 e to the 0.1 t plus 150 e to the negative 0.03 t. If the population was 200,000 bacteria when observation began, that's an important statement right there, what will the population be 12 hours later? All right, so we've got to find our function for population. Now, keep in mind it says the population T hours after observation begins is found to be changing at the rate. Do you remember derivative is a rate of change? So this is how the population is changing. So this is the derivative of the population function. And we need to get our population function. So we've got P of T is equal to the integral 200 e to the 0.1 t plus 150 e to the negative 0.03 t dt. Okay. And no, I know they have 0.1, negative 0.03. I just didn't put the 0 in front of the decimal. It's still the same thing. Okay. All right, so let's integrate this thing. So I get P of T is equal to 200 e to the 0.1 t, right? So the integral of e raised to the constant times t is just the same thing, and then what? Times the reciprocal of your constant, so that's over 0.1, plus 150 e to the negative 0.03 t, and then that's going to be over negative 0.03, and then plus, don't forget, plus your constant c. Okay. All right, so this is going to give me, this is after I kind of do my little arithmetic here, that's going to be 2,000 e to the 0.1 t minus 5,000 e to the negative 0.03 t plus c. All right. All right, so now let's look at this. And so we found the population. I need to figure out what C is. Well, what does this right here tell me? When the observation began, okay, T represents time. So when the observation began, in other words, when T equals 0, the population was 200,000. So that's telling me that if I evaluate P at 0, I should get 200,000 as an answer. So I've got P of 0 is equal to 2,000 e to the 0.1 times 0 minus 5,000 e to the negative 0.03 times 0 plus c, and that should equal 200,000. Now, do you agree with me? I'm gonna come up here and solve this for you. So do you agree that this is 1 and this is 1, because that's e raised to the 0 is 1. E raised to the 0 is 1. So what do I get? I get 2,000, right? That would just be 2,000 minus 5,000 is negative 3,000 plus my C equals 200,000. So C is equal to 203,000. And so I get P of T is equal to 2,000 e to the 0.1 t minus 5,000 e to the negative 0.03 t plus 203,000. See, we replaced the C with the 203,000. And they want to know the population 12 hours. Okay. 12 hours later. So that means T equals 12. And so we just take this, 2, 3, and we plug it in to T. Why did I put an equal sign? Minus 5,000 e to the negative 0.03 times 12 plus 203,000. And when you punch all that into your calculator, and this is going to be a rounded solution, so 206,152 would be the population. All right. I think now we got 2 more examples and we will be done. All right. So let's look at this. It says a retailer receives a shipment of 10,000 kilograms of rice that will be used up over a 5-month period at the constant rate of 2,000 kilograms per month. If storage costs are 1 cent per kilogram per month, how much will the retailer pay in storage costs over the next 5 months? Okay. So it says a retailer receives a shipment of 10,000 kilograms of rice that will be used up over a 5-month period at the constant rate of 2,000 kilograms per month. Okay. All right. So how much will they pay in storage? So we can say, okay, so let's just do S of T is storage cost. Okay, so all of this information is telling us like the rate of change of the storage cost. Okay, see it's let's see, will be used up over a 5-month period at the constant rate of 2,000 kilograms per month. So it's kind of telling us how that storage cost is changing, or we can figure that out. So if we have ds dt, okay, that is equal to, now let's think about how the storage, what the storage cost is. So it's going to be the monthly cost per kilogram, and we know, right, it's the monthly cost per kilogram times the number of kilograms. Well, the number of kilograms it's changing every month, right? And then that's going to be times the number of kilograms. Okay, so the monthly cost per kilogram is what? The storage costs are 1 cent per kilogram. So that's 0.01 times what? Times the number of kilograms. Well, how many kilograms are there? Well, the retailer, he receives 10,000, right? And then that would be minus what? Well, every month it's taking off 2,000 kilograms. So that would be minus 2,000 times T. Okay, T represents the month. So if you look at it, after the first month, that would be 2,000 gone, 10,000 minus 2,000. After the second month, another 2,000 would be gone. So 2 times 2,000, that would be a 4,000 total. And so we get ds dt is equal to 100 minus 20t. All right, because all I did distribute the 0.01. And so now I get s of t is equal to the integral 100 minus 20t dt. So s of t is 100t minus 10t squared, right? We add 1, so that would be t squared. The reciprocal of 2 is 1/2. 20 times 1/2 is 10. Okay, and then that would be plus c. All right, now we got to figure out what c is. Now, would you agree with me that s of 0, okay, so at the start of the first month, what was the storage cost? $0, right? Okay, so basically what it's saying is that's right when the shipment arrives. There's no cost. Okay, so we got s of 0 is 0. So s of 0, so we got to figure out what c is. So we're going to plug 0 in for t. That's 100 times 0 minus 10 times 0 squared, which should plus c equals 0. So this tells us that c is equal to 0, because see, that would be 0 there, so c is just 0. All right, so now I have s of t is equal to 100t minus 10t squared. There's my storage cost, and they want to know over the next 5 months. So that's going to be s of 5 is equal to 100 times 5 minus 10 times 5 squared, which is $250. All right, so if you've stayed with me this long, don't leave now. We got us a good problem coming up. All right, a car is traveling along a straight level road at 45 miles per hour, which is 66 feet per second. When the driver is forced to apply the brakes to avoid an accident, if the brakes supply a constant deceleration of 22 feet per second squared, which is 22 feet per second, how far does the car travel before coming to a complete stop? All right. So let's think about this. So what do we have? What do we have involved here? They give us a deceleration or acceleration that's negative, right? So we're looking at acceleration. We're looking at what else? Velocity, right? They give us the velocity. And we want to know how far does the car travel before coming to a stop. So that involves distance. So do you remember earlier in your course, wherever you're taking the class? I know if you were in my class, you've seen this before. Remember distance, velocity, acceleration. So if you have a position function and you take the derivative of that position function, that gives you the velocity. And then if you take the derivative of the velocity, that gives you acceleration. So basically, they're telling us, I hit another button. All right. So basically what they're telling us is that the acceleration is negative 22. That's how fast it's decelerating when we apply the brakes. So I've got the acceleration. I need to get to my position function so I know how far it traveled. So if I have acceleration, could I get velocity? Yeah, I could take the acceleration function and integrate it, and that would give me the velocity function, right? And then think about this. This is just mind-blowing here. Once I get the velocity function, if I integrate the velocity function, that's going to give me the position function. Look at there. We know how to work it now. All right. So, and of course, we're going to have constants and everything. So we're going to need some conditions to figure out what c is. But let's go ahead and integrate this thing. So I've got v of t is equal to negative 22t plus c. All right. Easy enough there. Now, do I have any information? That just doesn't look like a negative. Do I have any information that will help me get C? So let's look. A car is traveling along a straight level road at 45 miles per hour, 66 feet per second, when the driver is forced to apply the brakes. So we're talking about at the time he applies the brakes. At what time does he apply the brakes? Well, he applies the brakes at t equals 0. That's when we're starting everything. And at t equals 0, his speed is 45 miles per hour. But notice how our acceleration is in feet per second squared. So that's, instead of using miles per hour, we need to use feet per second. Oh, I was just wondering why they were giving us 66 feet per second in parentheses, right? You see that? They were nice to us on this problem. They didn't make us convert it. So what this is telling me is that v of 0, if I take 0 and plug it in for t, I should get 66 as an answer. So v of 0 is negative 22 times 0 plus c, which that should equal 66. And see, that's just 0, so that tells us c is 66. So v of t is equal to negative 22t plus 66. There's our velocity. Now we need our position function, so which that's s of t. Well, that's just the integral of the velocity function. Our position function is, that's negative 22t plus 66 dt. So let's integrate this. So I get s of t is equal to, so that's going to be t squared, right? Add 1, multiply by the reciprocal of your new exponent, which is 1/2. What's 1/2 times negative 22? That's right, it's negative 11, plus 66t, plus our constant. Oh, look at here, I'm going to use a d. Why did I use d? I don't know, I just did. That's the letter I picked. Okay? If you're just real passionate about it and you don't want to use C and D, you can use C1 and C2, constant 1, constant 2. Okay? That's perfectly fine too. But I just use C and D. It doesn't matter. All right, so now let's look at this. We've got S of 0. Okay, so let's think about this. So if you think about it, right when he applies the brakes, that very moment in time when he applies the brakes, how far has he gone before he started stopping? Well, 0 feet, right? Okay, because I mean, if you think about it, look at this. Let's just say this B here, that's the point that he's applied the brakes. So that car is coming down here, and this is where he applies the brakes. So from here this way, that's what all we're concerned about. This right here is where everything starts. Okay? So at time t equals 0, the distance he traveled is 0 feet. All right. So that's going to give me S of 0 is negative 11t, is negative 11 times 0 squared plus 66 times 0 plus d, and that should equal 0. And so this tells us that d is equal to 0, because all that's 0, so d is just 0. And so we get S of t is equal to negative 11 t squared plus 66t. There's my position function. Now we want to know how far did he travel before he came to a stop. That's what we need to know. So I need the distance that he traveled, which is S. Well, what do I plug in for t? That's the million-dollar question. I got to have something to plug in for t. Okay, so we need to know at what time did he stop. That's what we've got to know, the time that he stopped. How many seconds later did he stop? Well, now let me ask you this. Would you agree with me if I said that he comes to a stop when his velocity is 0? Right? That makes sense, doesn't it? When his velocity, how fast he's going, when that velocity, when it's 0, that means he's not moving anymore. So if we take the velocity, set it equal to 0, and solve for t, we get 3 seconds. So after 3 seconds, he came to a stop. That's the time that he came to a stop. So now if we take the t equals 3, plug it into our formula, or S of t, our position, that's 11 times 3 squared plus 66 times 3, and that is equal to 99 feet. And there's your answer. All right. So that was a fun little video. That's some pretty good stuff there, isn't it? All right, so I hope you enjoyed this video. Check out my other videos. Give me a like, share, subscribe, comment, and I will see y'all in the next one. Later.